Hello everyone, I welcome all once again to the mathematics class. In today's class, we want to continue with our current topic, the circle geometry. And if you can recall very well, we are going to observe that in the last class, we introduced the concept of circle geometry, and we talked about one theorem, and that is the theorem which tries to draw a relationship between angle at the center as well as the angle at the circumference. So, and we stated the theorem thus: angle at the center is twice the angle at the circumference. And today's class is going to be the continuation of that earlier class, so which talks about two additional theorems. The first one is the one which talks about angle in the same segment, and the other one is the one which also illustrates the case of angles in a semicircle. So, and I'm going to begin with the one talking about angle in the same segment. When we say any two or more angles are in the same segment, such an angle happens to be angle at the circumference of the circle. Now, with one notion, the notion is each of these angles which we are talking about or which we are referring to, we have common source. That is, each of these angles is going to have a common base. So, anything whereby we have such form of angle, that is what we call angle in the same segment. So, for instance, when we observe what we have here, we can see that for us to discuss angle in the same segment at all, it's making reference to angle at the circumference. So it's only angle at the circumference that has the property of being in the same segment. Now, when we observe this thing clearly, we are going to see that there are two angles at the circumference. This is one angle at the circumference, this is another angle at the circumference. Now, for us to be able to apply this property or to be able to apply this theorem is for us to first of all identify whether these two angles are on the same segment. And the two angles are going to be on the same segment as long as both angles has common source. Now, for me to determine whether this and this are on the same segment, so what I will do is I'm going to pick one of the two angles. So one of the angles I have here is angle X. So what I will do is, this is what we really call the angle. This part here is our angle. This vertex here, you can see this is the angle. So to this vertex there are two sides. This is one side, this is another side. Now what I will do is, from here I will keep moving until I reach the circumference of a circle, another point on this circle which I have here. So which means I will keep moving like this until I get here. So this is one point here, and the next thing is I will go to the vertex once again. So the other side of it, I will also keep moving until I reach what? The circumference of this circle. Remember, I said that the general term I make use of in terms of what? Circumference of a circle is what? Simply the body of the circle. So what I will do in this case is, from here I will keep moving until I reached the circumference of this circle, till I reached the body of the circle. So when I keep moving, though I come along the line here, but this is not the destination. The destination has to be what? That thing must be a contact between this line here and what? And the body of the circle, well, which we what call the circumference of the circle. So the movement will continue until I reach here. So I can say that this is another point where this line here touches the circumference or the body of the circle. Now what I will do is, there is a point here, there is a point here. I will try and connect the 2 points. So if I connect the 2 points, that can be done this way. So I can construct it like this. Now, so that shows that this angle is resting on what chord? This chord here. This chord which I have here. I can call this one P. I can call this one Q. Now for me to now determine whether this angle here, angle x2 here, is on the same segment as angle x1, so one thing must happen. What must happen is that this angle x here must also maintain the same base as the angle here. That is, from my angle, from my vertex here, if I'm able to connect from here to the circumference and from here to the circumference, if the two endpoints is also resting on this line, it automatically shows that this angle, since this angle is resting on the same chord this angle is resting, therefore angle S2 is what? In the same segment as angle X1. And when we try it, so we can see from this end, if I keep moving, so this is the point where I'm going to reach, it is point Q. From here, if I keep moving, this is the point where I will reach, which is point P. And when you observe the other time, you can see that for angle X1 here, they are both resting on PQ. Angle S2 is as well resting on PQ. It shows both have a common base of PQ. So any two angles that have such a property is what we termed angle in the same segment. And by the properties we want to apply, once we observe any two angles that happen to be in the same segment, so what it automatically means is that they will be equal, they will have the same value. For instance, this is angle 70 degree, so automatically this S2 is also going to be what? 70 degree. So that is one thing we want to talk about today. Now the other thing we want to talk about is the concept of angles in a semicircle. If you can recall very well, when I was trying to introduce the properties of circle, I made mention of what is called the diameter. We know diameter simply means a line that passes through the center of the circle. Now any angle I have at the circumference that has this diameter, this middle here, as its base, is what we call angle in a semicircle. Now let's assume this place, I can call it M and N. M and N. Suppose this MN is what? The chord, the base of the triangle which I have here. That is the base upon which this angle 90 degrees is resting. Do you get it? So it shows that what? Since the base of the angle I have here is diameter, then this angle here is automatically going to be what? 90 degree. So by the theorem, so the theorem states thus: angles in the same segment are equal. Now, why in the other theorem, angles in a semicircle is a right angle. So it is important one knows what do we call angle in the same segment as well as angle in a semicircle. Once those two concepts is clear, we can now apply it in solving questions. So we have an example 1 here. So in the example 1, in the figure below, line PQ is a diameter of circle PMQN, center O. If PQM is equal to 36 degree, find QNM. Now in circle geometry, I said it in the first class that it has to do with what? The application of properties to what? To relating with the diagram. Now when we observe this thing, now the first thing that should come to one's mind is which of the property are we going to make use of? So, and when we think of it now critically, we are going to observe that we've made mention of 3 properties. Now what we are now going to do is to think of which of the 3 properties is going to be useful in solving this question. Now if we can recall the properties we treated in the last class, that one was on angle at the center is twice one at the circumference. So when we observe this thing, we can see that we have angle at the circumference, but angle at the center is not stated in this situation. So that property of angle in the center is twice one at the circumference is of no use in this scenario. So it shows that we have 2 more properties we can make use of at hand. That is the case of angle in the same segment as well as angle in a semicircle. And when we look at this thing very well, we can now any of the 2 properties can come to our mind first. But the one I will love to use first is the one which talks about angle in the semicircle. So any of the two can come first. So it is unnecessary to make use of angle in the same segment, to as in to have it at the back of one's mind that angle in the same segment will have to be used first. So any of the two properties can come up first. Now I will love to make use of angle in semicircle first. Now for me to use angle in the semicircle, the first thing I'm going to locate is there a diameter here? Now the diameter, we call it a line that passes through the center of the circle. So we can see this is the center of the circle. The only line that passes through it is this line here, that is line PQ. So once we know PQ is a diameter, what we want to do is to find angle that is resting on this PQ. And doing that, you can see this P and Q has two end points here. This is one point here where this my finger is touching, and the other point is Q here where this finger is touching. So to get the angle at the circumference in this situation, what we do is this finger here, this my right finger, will keep moving until it reaches semicircle, and it touches what? The circumference of a circle, that is the body of a circle. So this one will keep moving like this. So this is the point where it touches body of the circle, or we can call circumference of the circle. The other finger here, the left hand here, so I will also allow it to keep moving until it reaches the body of the circle, or we can call the circumference of the circle. So the movement can be like this, so it will get it. So we can see that the two meet at this point here. So what the property is saying, this second property is saying now, is that any such angle that is resting on semicircle, or that have diameter, this chord that passes through the center as its base, such an angle will have the value of what? 90 degree. So that was the reason why it was stated in the theorem that angles in a semicircle is a right angle. That is, the value of such an angle is going to be equal to what? 90 degree, or what we can call the right angle. And by that theorem, by that property, so that's what we can achieve so far. Now the next thing is, let's make use of property of a triangle. Property of a triangle can be used there. That is, this is a triangle, PQM here is a triangle. So we can see that this angle is going to be 90, this angle is going to be 36 degrees. So what is this angle going to be? So doing this, we can say that addition of this angle as well as this angle is equal to 180 degree. So that is angle P here plus angle M here plus angle Q here gives the value of what? 180 degree. Now P is not known, so I will refer to it as P plus angle M here 90 degree plus angle Q here 36 degree gives the value of what? 180 degree, which shows that angle P plus 90 plus this is what? 126 degree is equal to 180 degree. Getting my P here means angle P is going to be 180 degree minus 126 degree. Now 180, 126, this is 4 and this is 5. So we can say the angle P here is 54 degree. So it shows that this angle here is equal to what? 54 degree. Now with this, we can now make reference to what exactly are we asked to do here. So we are now asked to find Q and M. So where is Q? Where is N? Where is M? So it is this angle we are interested in finding. Now what we are going to do here is we can now make use of the property of angle in the same segment. So doing that, what I'll be interested in is on what is the chord that serves as the base for this angle here. So this one can move this way, this one can move this way. We can see it is on chord MQ or chord QM. So we can see this angle here. This is one hand, this is the other hand here. So we can see it is on this chord called QM. Now let's now find, is there any other angle that is resting on what? On this QM. So we can see now, what we can do there is, let us pick this angle 54 degree which we have here. Now we can see this 54 degree which we have here has two sides. This is one side, this is the other side. Now what we are going to do is we want to trace it down to the what? To the body of the circle, what we can call the circumference of the circle, from this end here as well as from this end. So once it's also resting on QM, then it definitely shows that angle N and angle P are on the same segment. And once the both are on the same segment, they're automatically going to do what? To have the same value. Now let us try that. This is angle P, so we can move it here. This one can also be moved here. We can see that this angle 54 degree has as its base QM, just like this angle N has what? QM as its base. So it automatically means that this angle P and this angle N are on the same segment. And by the property, once we are able to observe that such two angles are having the same chord as their base, then the two angles will be equal. So this angle N here is as well equal to 54 degree. We can now conclude our answer by saying that what we are asked to do here, QNM is equal to what? 54 degree. That is, this angle N here is on the same segment as this angle P. Now that is one of the questions which we are going to solve in today's class. Now the next question, now let's assume we have this circle. This is the center, so we have it this way, then this way, this one to this side, and this one as well to this side. So we are told this is right angle. This point here, center, this is called L, this is called K. Why this is what? 53 degree. And we are asked to find the value of the marked angle in this scenario. Now when we observe this thing critically, we are going to see that making use of angle at the center is twice the angle at the circumference is of no use. So that's not going to be involved in solving this question. Now what we are now going to think of is either we make use of angle in the same segment, angle in the semicircle. And we can see the notion of semicircle is what is dictated in this question, because we were told that this is the center of the circle and there is a line which passes through it. So this is the diameter. And what one of the properties stated was that any angle that is line that has diameter as its base, such an angle has the value of 90 degree. So we can say this is diameter, this is the center. Definitely line that passes through the center is what we call diameter. In order to know that angle that is what resting on this semicircle, resting on this called diameter. So what we are going to do is we are going to pick 2 points of such a diameter. This is one point of the diameter, this is another end point of the diameter. So from here, from this finger here, I will keep moving until I reach the circumference of the circle, and from the other end here I will also keep moving until I reach here. So we can see that the 2 is going to be here. So it shows that the combination of these two angles are the angles that has this diameter as its base. So automatically the angle here is equal to 90 degree by the property which we are using. So which shows that K plus 53 degree is equal to 90 degree. So it might be necessary for one to state the theorem. The theorem states that what? Angles in a semicircle is 90 degree, or its right angle. So which means that K here becomes 90 degree minus 53 degree, and K gives the value of 47 degree. So that's the value of K. So the value can be inserted here. That is 47 degree. Now the next thing is to determine the value of L. So we can see the concept of angle in the same segment might not be of use here. So what we can make use of now is properties that talks about triangle. So we can see this is a straight line. So if this place is 90 degree, so we automatically know from property of angle between line that this place is going to be 90 degree. So we are now going to treat this triangle. So it shows that addition of the angle here, the angle here as well as the angle here is equal to 180 degree. That's by the property which states that sum of angle in a triangle is what? 180 degree. So it shows L plus this angle here 90 degree plus this angle here, it is K, but K has the value of 47 plus 47 degree is equal to 180 degree. Reason being that what? Sum of angles in a triangle is equal to 180 degree. So then we can say that L plus 90 plus 47 here gives 137 degree is equal to 180 degree. So L here becomes 180 degree minus 137 degree, and L here has the value of 180, 137, 3 here. This is 4, so which is equal to 43 degree. So it automatically shows that what? L has the value of 43 degree.